Hello, my name is Sebastian Hondel, and this is my card shuffling machine. This machine consists of three separate mechanisms. The first is the input mechanism, the second is the index mechanism, which is this big disc, and the third is the output mechanism. The input mechanism consists of a rack and pinion system controlled by a NEMA 17 stepper motor and a DC motor which controls the set of rollers that shoot the cards into the index mechanism. I decided to go with a NEMA 17 stepper motor over a servo because a NEMA 17 has a higher RPM and I can have more fine control than I would with a servo motor. This allows for faster insertion of the cards. I ended up having to add this 1/4-inch piece of MDF to the top to allow the final set of cards to grip the rack and pinion with enough friction to shoot them into the set of dual rollers. The second mechanism is the index mechanism. This is the cover which keeps the cards inside the mechanism. It also has a pivot point here which allows the cards to exit when it is time into the output mechanism. The index mechanism consists of a NEMA 17 stepper motor for precision control, which is just using a gear system to allow precision control of the index mechanism. This has 60 slots. I decided to go with 60 slots because it is a more easily divisible number. Even though there are only 52 cards in the deck, it would be easier for me to manufacture a gear reduction that would allow for a precision control of just this mechanism. If I went to 52, I would have had a way of having a more complex mechanism. Inside of this index mechanism, there is the pusher mechanism, which is controlled by a servo motor. This extends once all the cards have been inputted into the index mechanism. This increases where the cards are sitting at, so they stick farther outside of this mechanism, which causes them to impact the output mechanism and this roller. Once they impact the roller, the cards are then shot into the output area. I had to install this cover to prevent the cards from flying out the back of it, so this cover just sits right on top, and that keeps the cards all in place, and then once all the cards are in, you can just remove this very easily and pull your completely shuffled deck out. All the electronics are stored right back in here. We have the Arduino start button and the watchdog LED. We also have two stepper drivers which control each of the two stepper motors' input and index mechanisms. We also have an L298N motor driver which is used to control the two DC motors. There is a 9-volt battery which is connected to the Arduino to provide logic power, and then we have a 12-volt battery out the back which is designed to provide power to the stepper motors and the DC motors. I opted to have two batteries because if I only had the one 12-volt battery, the DC motors and the stepper motors would draw too much current when they started up or were stopping, that it would cause the Arduino to restart, completely screwing up the inner workings of the robot.